G'day everyone, welcome to Lubrication Experts. And today we have a returning guest to talk about all things varnish, which is like the hot topic. Excuse the pun. So Elaine is here this time in a slightly different capacity. So last time around, she was working at Polaris. In the intervening time period, has gone out on her own as an independent consultant, which is extremely exciting. And we'll talk a little bit about the kind of work that she's doing out in the field. But Elaine, thanks so much for returning.
Thank you. Thank you for having me. Happy to be back.
Now, Elaine is kind of like the varnish expert. Now, varnish, we're going to get into it, is it means different things to different people. It's almost like a Rorschach test, right? When you say the word varnish, often it can give you an insight into the kinds of applications that people are most interested in, because varnish has become this kind of catch-all term. So that's probably a good place to start. Is Elaine, we use this, we throw this term varnish around as if it is kind of one thing. But in my experience, and this is true. Let's say, for example, when you look at ICML's certifications, they've got these new badges for varnish identification and measurement, varnish prevention and removal. And even in that, right, in the course syllabus, they are talking about varnish as a range of different deposits. So there's hard varnish, soft varnish, varnish that's bound up in emulsions, there's soot type of varnish. It's kind of become this like sort of catch-all term. So maybe we could start there, which is like, what are kind of the major categories of varnish, and in what sort of applications do we typically see this stuff?
Okay, yeah. I mean, during my journey with my time at Polaris and overseeing the varnish program, it was interesting because, we did the standard MPC testing, which tells you the potential for varnish, but it really tells you like a color, because you're looking at the change of color and the deposits that are captured after, heating the sample and then letting it cool, allowing for that varnish to become insoluble and form those formations. And then you're filtering and diluting it down and then taking a color reading after the patch has been dry. So it tells you what your potential for varnish, but I think that in my experience, it only gives you a fraction of exactly what's going on, right? And so one day, Mr. Paul Whiting called me and he's like, "Hey, we have this really weird crystallized, clear, gummy deposit that we're seeing in the oil, and we don't know what it is. And we want to know, is it varnish? Is it not varnish?" And mind you, on this unit, we had already done varnish analysis and the patch was really gray. So keeping that in mind, you usually, during my training and my experience with analysis, whenever the patch is gray, that's an indication of microdieseling or ESD phenomena happening in the system. And that was about the extent of that. So the patch looked extremely gray. But I noticed on the patch for the MPC, there were like carbonaceous, like molecules, like particles. And so I called Paul and I said, "Listen, the patch itself, I studied it, looks really off. There's like some carbon on there. Let's try to do a micropatch analysis and let's see if the micropatch analysis will tell us something." Because at the time was when we were starting to see amber-like, abrasive, granular, hardened material in other components. So initially, when varnish was discovered by Dr. Zazaki well over 40 years ago, it was in turbines initially where we had found varnish. And for a long period of time, we thought it was just dedicated or just solely in turbines that we would see varnish. And that's not the case. Because through my work, we noticed as we did microscope analysis, we started to see varnish flakes, varnish formations in hydraulics and compressors. And so it was one of those where I was like, so varnish isn't exclusive to turbines. Could this be varnish? And I would kind of challenge the status quo, or challenge that and be like, that seems similar to what I see in patches, what we're finding here. And so that's where I recommended Paul to do a micropatch on the sample. And sure enough, the findings, we found clear hydrolyzed varnish with a carbon molecule encapsulated. It was a carbon molecule that was encapsulated by this clear varnish formation. And then upon further inspection, there was wear debris embedded in that molecule, in that particle. And so we knew something catastrophic was going on, but at least we were able to confirm and identify, hey, this isn't your standard amber, dark color, abrasive or gummy varnish deposit that we're used to. This is a clear, translucent, hydrolyzed kind of varnish. And so that started my rabbit hole journey into a 2-year study of doing samples and running a micropatch analysis alongside of it and comparing the MPC along with the microscope analysis to better help guide the customer and determine what kind of varnish formation is on here. And what I found is that varnish is unbiased. It can form in many different ways, shapes. Varnish is not limited to forming just because of extreme temperatures. You have ammonia that can react with it. You have different acids. You have metals that are catalysts. You have additives or ink fluid incompatibility. There's static that can impact that as well. So there's a lot of different sources or causes to varnish. And depending on the formulation, operation, machinery design, things like that, will have an impact on what kind of varnish you're going to have forming in your system. And so,
Maybe if
yeah,
we
go
can
ahead.
just jump in there,
Go ahead.
because
Yeah.
just to make sure that everyone is kind of at the same level here, because we're talking about two different kinds of tests. We're talking about MPC and micropatch. Maybe if we can
Mhm.
step back just to explain
Yes.
to viewers who might not be familiar with the two different test methods, like what is the differences between the two, as in how the test is done, and therefore how that impacts the kind of results that you can get out of the test.
Absolutely. So I'll start with MPC testing. So typically, what we do, or standard ASTM procedure, is you get 50 milliliters of oil. You put it into the oven around 50 to 60 degrees Fahrenheit, and you heat it in the oven for 24 hours. What you're doing at that point in time is you're heating up the oil and kind of reenacting the heating process or operational environment of that oil. And you're solubilizing, kind of mixing the insoluble varnish back into suspension. Okay. That's kind of like the whole purpose of it. You're restarting that process. When varnish cools, or when the oil cools, that's when insoluble varnish tends to bond and tends to adhere to polymers and additives and kind of drop out and form. That's your insoluble varnish. So you have four different stages of varnish. You have solubilized varnish, where it's suspended, and then once the oil cools down, you have your insoluble. Okay. So after the oil has been heated up, the varnish is suspended. It goes into the dark for 3 days. And the reason why it goes into the dark is because UV ray lights will impact varnish, have an influence on varnish formation. So because we want to keep data integrity, quality is important. It goes in the dark for 3 days. And then the cycle of the oil, cooling down, the formation of the varnish reoccurs. Take the oil sample out, mix it 50 milliliters with PET, 50 mils of the oil. You mix it and then you flush it, or you're filtering it onto a 0.45 micropatch or MPC patch, which is a little bit bigger than our micropatch sample or patch that's used. And then after that, you let the oil filter through. You're capturing all the insoluble varnish. Some of the soluble varnish may be captured, but some of the PET might wash it away. And so after that, it gets dried, and then you take a color reading. The color reading from 15 onward up to like around 30 is like anything above 35 is critical, but that's kind of your color reading. So based on your result determines the potential for varnish. So the higher your value, the more closer you are to 35, the more severe the varnish formation is going to be in your system. So ideally you want to be below 15. The closer you are to 0, the better. Okay. And so that's great. test for that. However, micropatch analysis is a little bit different.
Mm,
We don't heat the oil sample. We don't do anything. We get 1 milliliter of the oil sample. It's very well shaken. Take 1 milliliter, and then we mix it with either with heptane, and then we go through the same process of filtering that oil sample onto a zero point 0.8 micropatch, and it's very small. It's like about that big, not exact, but pretty small compared to your MPC patch, which is about a little bit bigger. So here, what we're trying to do is we're trying to capture any wear debris, varnish formation we have found gets very well embedded into these patches. And typically, this test is used for studying of different wear particles and contamination particles, like soft metals, like your brass, your bronze, your copper, lead, tin material, is ideal for doing micropatch analysis to kind of do, root cause or for checking for wear regime in the system. And so the same kind of methods applied when we're analyzing the varnish formation. So that's the goal of doing micropatch analysis, is that it's giving you a better idea of the type of varnish that's forming in your system. Is it a gummy, sticky deposit? Because if it is, it's going to absorb or abrasive material where debris will adhere to it. And now you have a very abrasive wear particle or particles circulating in your system, causing more damage. I've seen a varnish be very, very gold color like. So it tells me it's at the beginning stages of varnish formation, submicron, soluble varnish formation. So you're at the beginning stages. I've seen varnish particles that look like a tiger's tooth that is very, very hardened, very dark in color. So it gives you an idea of what varnish what type of varnish formations are occurring in the system, and are they impacting your day-to-day machinery and your operations, if that makes
mm.
sense. So that's kind of where my study and research on doing micropatch analysis came into play, because I wanted to give the customers a better understanding of the kind of varnish they have in their system to help them determine what is going to be the best varnish mitigation solution for them.
Yeah. So maybe a couple of things to note there. So
Yeah.
let's say, for example, with NPC analysis, you mentioned it was a what 0.45 micron patch. So that's
Mhm.
referring to the pore sizes in
Yes.
the filter paper, right? So effectively, you can think of stuff that's greater than 0.45 micron will be caught by the patch. Everything else will pass through. When Elaine mentioned that we are measuring the color, that's actually done in a similar way to if you've ever had a painter come around and sort of take colors of swatches or something like that, or
Mhm.
even up the paint against the wall in your house. It's done in a very similar way, except
Mhm.
that instead of measuring the color in, let's say, if you print, you do it in a RGB color space for red, green,
Mhm.
blue, or there's CMYK for printing for what cyan, magenta, K is for key, I
Never.
think. Which is the black. So in MPC analysis, we do it by LAB. So it's a
Mhm.
combination of like an L, an A, and a B value. Again, kind of referring almost to like darkness, hue, saturation, that sort of stuff.
Yes.
And we
Yes.
can get a little bit of information about the kind of varnish from the LAB values, but it
Yes.
doesn't have the same, let's say, resolution that you would get out of the
Mhm.
micropatch, where you can look at individual varnish particles and make an assessment. Well,
Mhm.
a skilled practitioner like Elaine can make an assessment of
Yeah.
what it actually is. So that's now kind of given us a flavor for, hey, varnish isn't just one thing. It is
Mhm.
this catch-all term that we are using for byproducts of hydrolysis. Like you said, you can get um, soot agglomerations. We can get more of that sort of hard baked on varnish,
Mhm.
sludges,
Yeah.
emulsions. And then you can get combinations of the two. So you talked about something like a wear particle being embedded inside of hydrolyzed material, which is then encapsulated by carbon. So that can be multiple processes that are going on at the same time. So given that,
Mhm.
maybe we can then start to talk about the the tool suite of varnish removal methods that we have, um,
Oh, yeah.
of which there are a ton of them on the market. So maybe we can talk in sort of like generic terms about
Mhm.
what are the generic approaches to varnish removal.
Sure, absolutely. There are, let's see, where do I start? Ion exchange, resin removal. They are good at removing varnish, some acids, neutralizing the acids, bringing it down. So they all of these technologies, I do want to kind of start with, they all serve their purpose and they all are very good in their own way, right? But there's not in my experience in doing this, there isn't an end all be all. Okay.
Mm.
There isn't. Let's be honest. And so, with this kind of resin media technology, it's got to find the right kind of bead that's compatible with the fluid formulation. So that's key to ensuring success in removal and varnish mitigation. Okay. Then there's the solubility enhancers, and they are really good at combating or changing and removing the varnish from the system. Okay, they're excellent at doing that. The
So
thing that
maybe
I've
maybe
observed,
just a maybe
yes,
just a point of clarification there. So when you use a solubility enhancer, it's you know, let's say for example, if most people think of dissolving sugar in water, right? So
yes,
as you heat up water, you're able to dissolve more sugar in the water. And then as you
hmm,
cool it down, some of that stuff's going to come out of solution. And that's how varnish kind of plates out in systems. When we're
yes,
using a solubility enhancer, it's not actually removing varnish from the system, though, right? So it is
no,
dissolving everything and it's keeping it in solution, but it hasn't disappeared, right? So it's
no,
just been dissolved, and then we would probably have to rely on some other kind of filtration technology to get those compounds
correct.
out of the system, right?
Correct. And I would say it like changes the chemistry of the varnish because it bonds together with the varnish molecule and changes the chemistry of the varnish. So that's kind of how it addresses that in a sense. It addresses the varnish issue.
Mm.
And you treat this depending on the sump capacity and the level of varnish contamination between 3 to 5%. That's kind of like around industry standard, 3 to 5% treat rate, no more than that. And what I've seen is you still have deposits. Unfortunately, oil as it ages or as it's put into use and other take into account environmental contaminants that get ingested or break and wear in a system naturally, or a seal gets blown or what have you, wear debris, you're going to have those deposits that unfortunately some of these technologies can't address or remove. And that's okay because their main purpose is to help solve the varnish problem. So I agree with you. That's where you would need to couple that with like some kind of offline kidney style filtration to remove the other hardened particles that cannot be addressed by this other technology. That's also amazing. And so there's also vacuum dehydrators that work with removing certain gases, separating some gas that's entrained with the oil, or even removing water, and they're very effective, but they don't address other issues like the contamination or the varnish. But you might have a system where, again, if there's high amounts of water contamination and you have varnish, you might run into hydrolysis. So this is kind of where, using one or more technologies might benefit you because now you're getting a well-rounded varnish mitigation solution implemented for your system, if that makes sense.
Yeah. So maybe we can get into. I know you presented a case study at the recent STLE annual general meeting, um,
Yeah.
which I think was sort of an interesting one. There's a technology that we've both worked with called Delta Zero, which was kind
Mhm.
of foundational to that case study. So maybe could you please help us like, set the scene for what's the application that we were talking about,
Mhm.
maybe the sort of the levels of contaminant and varnish that were in the system, and what did you see over time?
Yeah, absolutely. So over a year ago, as you know, I decided to start my own consulting business. So it was my first customer ever, Kimbro, hired me on. They had experienced, or they had a customer, they came across uh, hydraulic forge press that was about 35,000 gallons of oil, which is around about 132,000 liters of oil for my UK non-US colleagues watching this podcast. So it was an ISO 68 hydraulic oil, and they had been experiencing varnish for the course of 8 years. The machine was about 10 years old. Okay. And they had hired me on to come down and do varnish training, kind of explain to them the work that I do, the test methodology, talking about ruler, MPC, all of that, and also introduce micropatch analysis to monitor the varnish formation. And I went down there, did my training, they liked it, and then they asked me the $1 million question that I get asked quite a bit from customers. What is the solution that you recommend? And my suggestion was, well, with 8 years of varnish buildup, you're going to need to have something that's going to remove a lot of that debris and contamination from the system. So it was recommended for them to use Delta Zero. And so that's kind of where we started. But I want to talk a little bit about the issues that they were having, okay? Because I think that's important to discuss, in a operational environment, what kind of challenges you'll be faced with. So this is a little bit different than your traditional turbine system, right? This is hydraulic system, large hydraulic forge, which has its own building dedicated to it. Like we had to go down 2 flights of stairs into the basement just to gain access to this machinery, and it's very loud. So they're forging titanium, okay, and they were using part of their forging process. Carbon was also being used, okay. And so
Mhm.
one of the things that we found, and one of the things that we were removing a lot of, was carbon deposits, and that's because it's part of the environmental operational contamination. So you're going to deal with some of that. So high operational temperatures, high presence of carbon, we were dealing, or the customer was dealing with, on a monthly basis, having to clean their valves because they were getting stuck, and they were getting caked with baked on carbonized hard varnish on the surfaces. Okay. So they were doing that every year. They had experienced a couple of fires as well. And so it was a multitude of high operational temperature, exposure to a lot of carbon, and it just was a perfect combination for varnish to start forming in the system. And they each month they were having high volume top ups, anywhere from 1,200 to 1,500 gallons of oil each month. Okay. And at the time, they had mentioned to us that they did try to use and treated their system with solubility enhancers. And that was great. That did help for a while, solve the varnish issue. However, because of the frequent top ups each month, they ended up diluting that ratio. And then now that solubility enhancer was no longer able to maintain or, catch up to the varnish formation. So it was just a continuous thing. And so we installed 2 large 12 banks, which is the largest filtration units, along with MP Filtry particle counters in line. And we started our process. And we began with an MPC value of around 41. And then till we finally dropped it down to 16. But in the process, there were, every 3 months, we changed the filters. And the key thing here was proving to the customer that we were removing all the contamination. Now, mind you, very, very important to state this. I bet you get asked this all the time. The $1 million question: how long is it going to take for you to remove varnish from my system? I'm sure you get asked that question all the time.
Mm.
Do you?
Yeah, yeah, yeah.
And usually, what's your response to them?
'Cause it depends.
Exactly. Exactly. It really does depend. It's kind of hard to guess how much varnish is in the system. Some of these units are caked with varnish, but it's not like you can drop a boroscope into the sump and get a camera in and see how much varnish is in the system. You're talking about these hydraulic systems that have all these hoses. A lot of that varnish has built up in that. Not only those hoses, you're talking about all the surfaces, the pistons, the valves, the solenoids, everything. I mean, it's going to be everywhere. Even on your heat exchangers, you're going to see varnish caked on there. Anywhere where it's cold, you're going to see high amounts. So we had no idea just how heavily contaminated this system was until we were at our second oil change. I mean, filter change, correction, filter change. And each time we weighed the filters themselves, without being full, weigh about, I want to say 3.5 pounds. So they're pretty light. They're pretty light. Okay. The first filter change, after we removed the filter, it weighed about 7.65 pounds.
And in the second filter change, which is where we left off, we weighed each filter. Each filter weighed 11.4 pounds, and the actual weight after we removed the weight of the filters when they were not filled or at capacity was 6.8 pounds of each. Okay, so 6.8 pounds is what they ended up weighing. So total was 163.8 pounds of varnish and other debris were removed from the second filter change. So taking into account the weight of the first filter change plus the second filter change, we are at a total of 347.4 pounds of varnish and other debris that has been removed from the system. So at this point in time, Paul and we were seeing that there was a lot more varnish in the system than we had initially anticipated. We thought two 12 banks, which is the largest GX filtration units, would have been enough because we were turning over 35,000 gallons of this oil once a week, which is pretty good. However, it wasn't enough to remove all of that varnish that we were capturing and removing from the surfaces and the bottom of the hydraulic unit. So we, at that point in time, decided we were going to install two more Delta Zero 12 banks. So in total, this system has four 12 banks installed.
So that's 48
in the system.
cartridges working at any one time, right?
Correct. So instead of filtering it once a week, we were kind of filtering that oil and turning it over two times a week. For that volume is pretty good. And so one of the things that we ended up finding was there was more higher presence of varnish on the left hand side of the system because there's two large reservoir units. We had a yellow unit on the right hand side and we had a red unit on the left hand side. And when we were comparing samples and doing the analysis, we noticed that the yellow side was lower on MPC, where the red side was higher on MPC. And the reason for that is because the top ups, the volume top ups, was taking place on the yellow side. So that oil was starting off, or that side of the unit was starting off with fresh oil. And then as it was circulating in the system, the red unit was kind of capturing all of that other high concentration of varnish. What we did see was a lot of varnish, softer particles of varnish, a lot of carbon, hardened, dark material that we were kind of picking up, kind of amber-like. So we knew that there was quite a bit of varnish that did accumulate in the system over the course of 8 years. So mind you, they had only used soluble enhancers in the past, but they had never complemented any of that with offline filtration. So Delta Zero came in and was removing all years worth of buildup over time. So then in January, 3 months later, once 48 cartridges, we went and changed them. So at this point in time, each filter weighed around 6.93 pounds of dirt, or dirt capacity, okay? Total of 332 pounds of varnish on the third filter change. Okay, so you have 347 pounds plus 332 pounds of varnish, equaling a total of 680 pounds of varnish that has been removed from the system year to date. And at this point, the MPC value had dropped to 16. So we had removed a significant amount of varnish, carbon that we saw on the filter debris analysis. We were able to remove all of that. But what we found was a lot of carbon was also present in the oil, or what we were removing from the filters. And we believe this is a mix of the byproduct of the carbon being used to forge the metal that they were working with. In this instance, it was titanium. In other instance where that carbon could have been coming from as well is due to the high operational temperatures of the unit as well. So some of it was a mix of environmental ingestion contamination due to the operational process, and some of it internally from within the system itself as well.
Yeah, cool. And that sort of gets to the point that we talked about earlier, where there's multiple different kinds of varnish. And so you guys are having to target multiple different, let's say, like oil failure modes, for want of a better word.
Absolutely. Yes. And in my experience with doing microscope analysis of varnish formation, I have found in systems where you can have various different types of varnish stages or formations all in one. Like, for example, there was a hydraulic unit where you had a granular, very fine sand-like varnish, as well as hardened crystallized particles of varnish. And then, the varnish that kind of is like a lacquer, smooth like paint layer on the surfaces of the system. This unit had all three different types of varnish in the system. So I found that pretty eye-opening and astonishing as well, to see that it's not uniform. Varnish isn't a uniform formation in systems. It really, you can have a variety of varnish in your system as well.
Yeah, and that's really interesting because I think, one of the analogies that we always give is, oil is like the blood of a machine, right? And it circulates, byproducts, and in many respects, if you thought of a machine as being a human, the byproducts are it's kind of like the symptoms of an illness, of a sickness. And we shouldn't be surprised that there are, multiple illnesses that machines can suffer from. Interestingly, we're very comfortable in healthcare with the idea that every sickness requires a very specific and tailored solution to it, right? The drugs that you would take for, let's say, the flu are entirely different to what you would take for a stomach bug. Uh, and yet up until this point, we've kind of used a very blunt instrument, right? In that,
Mhm.
all contamination problems seem to get hit with the same solution, which up until this point has just been, chuck a depth media cartridge on it, sort of thing, right?
Absolutely. And I think this is kind of where, I suggest that being open to the idea of using different technologies together to maximize your efficiency of cleanliness and optimizing the longevity of the fluid, while also optimizing the life cycle of the equipment, is key. For example, complementing a system that has gross amount of contamination, or water contamination for that example. Some filtration systems alone are not set up to, remove gross amounts of water. That's where vacuum dehydrators or coalescer filtration units can come into play. Or depending on how high your acid level could be as well, some filtration units can't handle that acidity. I mean, they might help aid in dropping it, but they have other technology out there. So I think that it is something where Delta Zero on its own is a very effective filtration system that I've seen being close to being the end all be all in some instances, to be honest with you. But I've also seen where you can actually complement that technology with even like a enhancer, a solubility enhancer, to even be more. The solubility enhancer can come in and address the varnish, where the filtration unit can help address the other contamination, where the solubility enhancer may not be able to kind of address that. You see what I'm saying? So, one of the things I like to discuss with my customers when I'm talking about this is being open to possibly using two different kinds of technologies to kind of address all symptoms. Kind of like when you go to the doctor, right? You have multiple things. You're going to need multiple medications to address each and every one. It's not like you have a magic pill that you can take to take care of everything. You know what I mean?
Yeah, yeah, and
That's
to your
what
point,
I'm,
like some of
yeah.
these solubility enhancers that have hit the market, I've seen them used to really good effect. I think um, one of the challenges that they have is definitely with inorganic contaminants. And so
Mhm.
in that's one area where a sort of a two-pronged approach for both organic and inorganic contamination makes a lot of sense. Um, yeah, that's really interesting. So is that where you sort of see the future of all these technologies going? Is like, specific remedies for specific,
Mhm.
let's say, machine illnesses?
Yes, I actually do see, the future being more of collaborations between different technologies out there to maximize your results, especially for customers out there. We're in the field to help people and help, companies save money and extend the life of their equipment. And so, yeah, I think that, in the 16 years that I've been doing this, um, I have yet to see something that's an end all be all. Like, I told you the magic pill. Um, and I have seen success with different technologies when they come into play. I've seen success with vacuum dehydrators plus a filtration unit to help mitigate the water, but also address the contamination.
Mm,
So, it's interesting and I hope to see more of it. I hope to see more of a conversation about it as well, and people being a bit more open-minded on that, where they're not stuck on one kind of technology is the only thing that they could use, being open to blending two different kinds of technologies to maximize your results, and then also having a bit of patience. I think that's important. I'm sure you get asked a lot, how long is it going to take to take care of my system?
oh,
If you've been suffering from cholesterol for several years, you're not going to get over your cholesterol in a month. It's not going to clear by just taking medicine, taking a statin. That's not going to clear your system. You have to have a good diet and exercise, take your medication and be vigilant over a course of time. And so I think that's also, something that's important is we want to see results overnight. And by all means, there are technologies out there that will provide results overnight. It's a case by case basis.
yeah.
Not every varnish case is the exact same. Everything's different. And just kind of having an approach of, you know, this is a marathon, not a sprint. It's a journey, not something that's quick. So just kind of being open to that as well, understanding the level of contamination, how heavily contaminated the system is, and understanding that it's not going to happen overnight. In some cases, again, like I've said, in some cases you will see it in 72 hours go away. But you still have to maintain it. You still have to stick with it in the long term. You know what I
Yeah.
mean?
Yeah.
You know,
And I think one of the keys that that I've been thinking about as we've gone through this conversation, before the cure, you have to get diagnosed, right? So and I think that's one thing that we're not doing is that people say, "Oh, I have varnish," right? And they go straight to a
hmm
cure. There is a step in there that needs to be, well, let's take a sample of the deposit. Let's analyze what the
hmm
deposit is. Let's
hmm
see exactly what kind of varnish is in the system. And then we can,
hmm
like a good doctor, prescribe the correct cure for the system. And if anyone needs help with that, reach out to Elaine because I can't think of anyone who's kind of better at doing that kind of level of diagnosis and who has more experience with doing it. So if you have a varnish issue, before you jump to a cure, come see Dr. Hepley. for, we need a different term for Elaine Hepley, MD, but for lubricants. Maybe it's LD or something like that. No, that'd be great. So hey, Elaine, thanks so much for covering, everything that we went through, you know, different types and characterizations of varnish and getting us to sort of broaden our minds and think about different kinds of failure modes that are occurring within the oil and how contaminants can also contribute to deposit buildup. And then going through and stepping through that sort of awesome case study. I mean, who would have thought over 600 pounds of varnish removed from a single system is just insane. And from what I understand, it continues on to this day, right? So if anyone
Yeah.
is curious about any of that, please reach out to Elaine. And yeah, no, we'll have to have you on another time.
Absolutely. Thank you so much for having me. You guys have a great day and cheers and well wishes from Guatemala.
Awesome.